So hello everybody and welcome to my talk about behavior-driven integration with Cucumber and Citrus. My name is Christoph and I'm working as a software developer in Germany. And in the next 30 minutes we will handle two frameworks. First is Cucumber, which is covering the behavior-driven aspects. And the second one is Citrus, which is a messaging integration testing platform. So you can test your interfaces to other components, and we will have a small demo application talking with HTTP REST and JMS and mail communication. And we will combine these two frameworks in order to have automated integration tests with behavior-driven aspects. So let's start with behavior-driven development. A short raise of hands. Who is actually working with BDD right now? Yeah, good. I would say half of the people here. And especially with Cucumber? Raise your hands. Okay. So behavior-driven development is about communication. So communication between teams or between companies, communication between people. And in software development, we have domain experts, and this group of people, they know exactly what is the business value of the company and how to create the business value. They know exactly how the user experience and the user stories are, so they know exactly what is to be done, and they have new ideas how to create new features, new business value. And not necessarily these people know how to write software, and this is our job. So software development comes in, and we have to implement new features, we have to add new components, and this based on the knowledge that is provided by the domain experts. So we have to find some way of communication between development and the domain experts. Maybe this is in one company, maybe these are separated in two companies or more companies, so that the domain experts to deliver knowledge to an external company that writes software for them. And at this very early state of software development, things can go deeply wrong. When the communication is bad, or when there are misunderstandings or unclear requirements, all these lead to bugs and to misbehavior in production, and we don't have, or we didn't write a single line of code yet. And this is a very early state of failure. And behavior-driven development tries to give us some tooling and some concepts to improve that. So it's all about explaining behavior of software. And if you explain your thoughts and your ideas to another person, it's a very good idea to give concrete examples. So if you have something in your mind and you want to explain it to another person and it's a very complex scenario, you can give concrete examples so the other person can rethink your ideas and can just imagine what you are trying to explain. And this is where Gherkin comes in. So in behavior-driven development, we have this specification language, and this language gives us some keywords in order to explain our thoughts, in order to write down our features in a good way. And these keywords are given a certain context. When some event happens, then an outcome should occur. And this given when then structure has been proven to be very effective when it comes to writing down your features and your what is your context, what is the event, and what is the outcome. And everybody should understand that. So I also give a concrete example. We will have a small sample application. I can show you this application. It's running on my local machine. So it's a very simple Spring Boot application. We have votings. We can add new votings like, did you enjoy the crab sandwich? Or other stuff like, do you like Java 9? And you can open the voting and it's very simple. And as you can see, you can do multiple voting. So nothing fancy here. If I close a voting, then no further votes are accepted, And this is basically our application that we want to test right now. Very simple. So a feature specification for this application could look like this. For creating a voting as a user, I want to create new votings, and each voting should have default vote options. So I describe my scenario, I give a voting title, and this is where the very concrete example starts. So I say, given voting title, do you like Devoxx? When I create the new voting, then the voting should have two options. These are the default options, yes and no. And of course, a feature is described with multiple scenarios, so I can add another scenario for custom vote options. I give another concrete example. When I create new voting, what type of Devoxx ticket do you have? And the voting options are university, conference, and combi. Then the voting should have these options instead of the default options, yes and no. And the good thing about that is that it is using the domain-specific wording, like create a voting, do vote options, have vote results, and everything. This is domain-specific wording, and it's readable throughout the company. So domain experts, product managers, developers, testers, everybody can read it, and everybody is able to understand what is the feature, what is the scope of the feature, what is included, what is not included. And that is the basic idea. And Cucumber as a framework can read these specification files and make them executable as unit tests. And we're going to have a look at that. So if you want to use Cucumber, to my knowledge, there is JUnit 4 support. JUnit 5 is planned, but it is not released yet. So I have a JUnit 4 run with annotation. I use a Cucumber runner, and this Cucumber JUnit runner will have a look in the same package as the testing class, and will look for those feature files. And these feature files are ending or file extension with .feature and are using this Gherkin given when then structure. So Cucumber will load those files and execute those as unit tests. And what we have to do is we have to translate the statements in the feature files to executable Java code. And this is done in the so-called step definitions. And if I have in my feature specification a line, when I create new voting and that title, I should have some method in my step definition classes which is annotated with the @when annotation. And this annotation gets a regular expression. And this regular expression should match my statement in the feature specification. So the regular expression says I create new voting, and then the expression uses a regular expression capturing group. And this capturing group is there to dynamically inject the title of the new voting as a method argument. So we have this method argument string title, and this is then the actual title that was specified in the specification. And in that method, I can do normal unit testing code. So I create a new voting ID, I create a new voting instance, I give the title, and I call the voting service to add this new voting. So it's a normal unit testing code. And then in the assertion step, I would have then voting should have three options. Again, I have a method with the @then annotation using a regular expression and using the capturing groups to pass in the amount of options. Here I'm using an integer, so it's automatically converting the types here. And then I can do a normal JUnit assertion as I would do in a normal unit test. So the idea is that I have these feature specifications, and the feature specification drive the method execution that I have prepared. I have some syntax options here for more structured data, like having multiple columns and multiple rows in this data table, and Cucumber will automatically convert this in a data table object. It is passed in as a method argument of type data table, and then in the method I can do everything on this data table. I can walk through the columns and see what I can do with this data table. It's syntax sugar. So first demo, let's have a look at this. Once again, I have prepared this voting application. By the way, the demo code is available at GitHub and should be working on your machine. And at the last slide, I show you the GitHub link. So it's a very simple Spring Boot web application, nothing fancy. We have some controllers, we have some services, model objects, and in-memory database. So really, really simple. And I have this test which is running with Cucumber, and of course the feature specifications. And the good thing is that I can just execute that as a normal unit test, because the basis is JUnit. You can execute that. Hopefully you can see that. Just went through very quick. And this is what unit tests should do. They should run very quick. And the good integration into the Java IDE is that I have this syntax highlighting of the keywords given when then. I see the regular expression capturing groups. They are highlighted, the dynamic title here. And I can also jump into the implementing method. So if I jump into it, Cucumber extension here knows the implementing method. And this is quite good integration into the Java IDE. Good, that's it for the first demo. There's more to come. So what else do we have? We have background steps. These steps are common for the whole feature file. These are common steps that should be executed before each scenario. So I do not have to repeat the steps every time in each scenario. I can give some background steps and Cucumber will execute these steps before the scenarios. Another nice feature is the scenario outline. That's a good way to pass in some test data that is having here some placeholders in my scenario outline, like the title or the yes vote, no votes. And at the very bottom, I give a data table of example data, and Cucumber will just run through the whole examples and execute this scenario with each test data. And of course, all the test data should pass, so the test is passing. Okay, so this was the short introduction to Cucumber. Now we will combine these concepts with Citrus. So Citrus is an integration testing tool for messaging integration. So messaging integration, we have like monoliths divided into smaller pieces of software, smaller services, standalone services, and all these services do exchange data over messaging. Typically, this is an HTTP REST interface, or of course JMS. We have asynchronous communication over JMS, or we exchange data via FTP protocol, or we send out some emails. Everything is a messaging interface to another component that is not necessarily running on the same JVM. It could be running on a very different server. So staying in this voting application, in the middle we have this voting app, and surrounding we have other components that either call services on the voting app, or the voting app is calling those services. So clients send in some JMS or HTTP requests, and when a voting is closed, then a reporting server should receive a JMS message. Okay, the voting is finished, the top results and the top votes are, and of course all the participants should receive an email that the voting has finished and the results are. And this small application has 3 different interfaces of different kinds. So we have HTTP REST, JMS, and mail communication, and we want to test this in an integration test scenario. And in such a scenario, Citrus as a framework is able to simulate all the surrounding components. So I have the voting application, I have it deployed somewhere. Now it is running on my local host machine, but it could also be deployed on an application server. It could be deployed in Docker, in Kubernetes, OpenShift. It could be an Achillean micro deployment, whatever you like. But you have a deployment somewhere that is your system under test in the middle, and Citrus is able to fire in some messages and at the same time receive some messages as the JMS reporting, for example, or receive the mail content on the right-hand side. And we will have a look at this. So if you want to combine Citrus and Cucumber, you have to do one critical thing. This is setting the Citrus object factory. So this is the object factory written in Citrus to provide the Citrus extension to Cucumber. And you can do this in the cucumber.properties file, or you can set this via system properties. But everything else stays the same. We still have a normal unit test, a normal JUnit test that uses the normal Cucumber runner, and we still have a feature specification with the domain-specific wording like create new voting and the voting's top votes are and so on. But in the background, we do not execute unit testing code. We use Citrus to really send out an HTTP call. And we really want to receive that JMS message. And at the very bottom, when I say, then participants should receive reporting email, then I really want to have this email send out, received, and I want to compare the email content to what is given here as a mail body. And the Citrus object factory is enabling some new annotations that we can use in our step classes, like the Citrus endpoint annotation that injects a ready-to-use component that is provided by Citrus. Here it is the HTTP client and the mail server, and we can then use them, these components, in our tests. And second, the test runner. And this test runner object is our entrance to the Citrus Java Fluent API. And Citrus provides Fluent API for sending out messages, for receiving messages, for querying the database, for doing something with Docker containers, for interacting with Apache Camel or Aquilion. All that stuff is in the runner API. Right here, we just call the runner.http, and we give the voting client as a component, and then we send out a delete operation on /voting, and this will then just send out the HTTP call, and we want to receive a response, and this response is supposed to be HTTP status OK. So every time Citrus receives a message, you can give an expected message content. So you can give just message header information, you can give payload information, you can use XPath or JSON path validation here. So this is all on the runner API. Right here we receive that response and we just check that it's an HTTP status OK. So the ready-to-use components that I have mentioned, these are simple configuration. Here it is added as a Spring Bean configuration. So I have like the HTTP client. I say, okay, the server, which is the voting application, is running on my local host on port 8080, and I want to be able to send in some calls in here. So I have the voting client and the mail server. This is a full mail server that is automatically starting up when Citrus starts and is listening on a port, and incoming emails are passed to the test for validation and for comparison with an expected message content. And Citrus provides lots of other components that are usable in that same way. So not only HTTP server components and JMS, we have SOAP web services, Docker, Camel integration, which is really cool because you can use all the Camel components out there to use these components within your Citrus test. And Selenium integration, we will see this later on in the demo. So there are lots of components ready to use as we will see this in the demo. So for receiving a mail content, we also use the runner API. We say runner.receive. We just say, okay, now the mail server is our endpoint that we receive the message from, and we can give an expected mail message content. And this mail content, of course, has a from, a to, a mail subject, and the body is passed in again as a method argument coming from the Cucumber specification file. And then Citrus is able to really do a very powerful comparison of the real message that arrived at the mail server and this expected content. So every time I do a receive, I give an expected message content, and Citrus will compare these messages for JSON, for XML, for plain text, and has a really powerful comparison of these. So you can ignore some sub-elements, and you can use dynamic data and validation matchers. You can do Humcrest assertions, everything. So I cannot show you everything here, but it's really, really powerful. And once I receive that message, then I want to send back some response as the mail server. So I give Citrus the response here. This is an SMTP protocol 250 OK. So email was accepted. And at this point, I can also do some negative testing. Yeah, so this is the happy path. I could also say now the mail server should send back some error, like I did not accept your email, and the voting application should handle that. A short JMS messaging sample, the idea is simple, is always the same. I have a JMS endpoint. This is an asynchronous endpoint, has some connection factory and some destination name, a topic or a queue, and then I can use that endpoint in my class with the Citrus endpoint annotation, and I can use that on a runner API to say runner.receive reporting endpoint, and right here I'm using the JSON payload, and once again, this is very, very powerful. You can use variables that you created before. These are then automatically exchanged. You can ignore some sub-elements, and the order of JSON arrays and stuff like that is not important. Everything that you need is there in the very powerful validation. Okay, lots of talking. Let's have a look at this in a running demo, hopefully running. So let me close that. Don't need that. Yeah. So yeah, this is the feature specification, and as I said before, in the background I am using the runner to send out some real HTTP call or to receive the real JMS message, and still I'm able to just execute that as a normal JUnit test. The voting application is running on my local host, so the system under test is deployed somewhere, and now Citrus will just call that, and when the mail is sent out, Citrus will receive the mail, and the mail content is automatically compared and validated. So we have these implicit assertions. Yeah, so green test, that's good. So maybe let's have a failing test also. Maybe in the mail, if I jump into that and say the voting or the subject, like vote results instead of voting results. So my expectation is now wrong, and we should have a failing test because the comparison of the mail content is not as expected, and we should receive a red test here. Come on. Yeah. So yeah, hopefully you can see that. This is a typical validation error in Citrus. So we have the subject expected was vote results, and it is voting results as expected here. So let's fix that. Okay, so this is the basic idea. We have these voting feature files. We can use domain-specific wording, and we use the runner API to just call HTTP calls and everything. But there's even more. So Citrus just goes a little bit further and provides some default step definitions. So these step definitions I had to write on my own, and I had to write manually, calling the runner API. That's fair enough, but I can have also some default steps, and you can activate those in your test with the Cucumber options, and this so-called glue code is ready to use, provided by Citrus. We have many different packages. Right now I'm using the core steps and the HTTP steps, And if you do that, you can just create a test that uses wording like this. So when we clear the voting list, send delete on/voting, then receive status 200 OK. And this test is running out of the box with the Cucumber Citrus integration. If I jump into that, you see on the left-hand side that this is included in the Citrus Cucumber jar file. So I do not have to write this glue code on my own. I can reuse it. And if you have a look at that, it's pretty complete here. We can have a payload, a JSON payload, set the content type, send a post request on/voting, then receive status 200 OK. I can also receive some messages here. So when I send get on/voting, getting the whole voting list, I can validate using JSON path that I have one voting and that the title is as expected. So you can use all of that out of the box. And another nice feature that I want to show you is the Selenium integration. So it's basically the same idea. I have this Selenium test where I use the predefined Selenium steps from Citrus. And once I have done this, I can write tests like this here. When user starts browser and user navigates to localhost 8080, then page should display the link with run application. Or when I just go in here, user clicks a link with run application, then I sleep. Sleep is also some predefined step from Citrus. And then I can do some validation on the page using the normal Selenium web components and web elements, having some clicks on the page. And this is a complete different way of writing Selenium tests as right now. So maybe let's execute those tests here. So hopefully now my browser should start and should drive Selenium through the application, adding some votings here. And this is just like normal Selenium integration. You can click, you can fill in some form fields, you can validate that some fields are displayed right now. And yeah, that's pretty much the Selenium integration. And the good thing is you don't have to write all that glue code on your own, but you are still able to extend or to just write your own step definitions and use them in the mix. So when I go in here and say and I'm in the wrong, maybe I go in here. Yeah, so I have not loaded my custom step definitions into the Cucumber options. I did it here, so I can mix. Yeah, I can have domain-specific things. In the next line, I can use some predefined steps from Citrus. I can use some HTTP calls. I can use some JMS calls. I can use some Selenium code, and I can mix those in a feature specification. And still, everyone should be reading or should be able to read this specification and should be able to handle this. And this is a discussion baseline for discussing your features with the domain experts or with the product managers. And of course, when you as a developer implemented the feature, you have to prove to the product manager that you implemented the feature as expected, and these feature files can be the basis for these tests and for these acceptance tests. So this is basically everything that I wanted to show you. Let me show you the last slide, which says the demo source is available at GitHub. You can clone it and it should be executable on your local machine. And I'm happy. I have 30 seconds left for maybe one question. Is there a question? If not, or if you have a question in mind, please come to the front. I'm happy to answer your questions. And I thank you very much for your attendance. Thank you.